So I've been to Barnes & Noble and I picked like a fast reader book because I thought it's pretty small, and I'll tell you it's very simple, and it really makes you understand the deeper levels and have deeper questions, just but simply explained. And it's called Seven Brief Lessons on Physics by Carlo Rovelli. It's a book that explains everything, as I said, pretty simple. It tells you how it started, where it's going, different theories, and a simple language so me and you can read and have an idea. But it also creates deeper questions, like you start to think, is this exactly what we see? Do we as humans really see the reality as it is, or don't we see it as it is? And from this book, I understand that physics teaches us that the reality is not object-based, but it's more like a process-based system, and that electrons, protons, quarks, no matter how we see them, how we perceive them, they are just different expressions of the same underlying field. So it's like, I'm not sure if this is a good example because I'm not a physicist, but in my mind, it's more like water. It can be gas, it can be liquid, and it can be solid, right? And if you take the ice and it's solid and you leave it on the table, it becomes liquid. If you leave it for too long, it evaporates. So to me, electrons, protons, and quarks and neutrons, everything is like the same thing. It's just the same matter, but it's just expressing itself in different ways, so that makes the particles more like temporary things instead of like permanent things. And because the time flows differently for us, we do see things like solids. We don't see what's underneath. So we will know that if you look deep inside, it's more like empty space, and rather than having anything inside the atoms or any object. So, but we perceive it as solid, like we perceive it as a table, or I don't know, as a chair, when in reality it's just empty space. And because our brain doesn't see everything as deep as it is, we just perceive anything as being more like a thing. But when you think deeper, a proton or anything really, any particle is an allowed configuration of fields that is present right now. And thinking of it as being solid and also empty are both the right way to think, is because there's different layers of reality. The reality you want to see. Do you want to, if you wouldn't look deep inside into a table or a hair, what's this called? Hairband. Or a hairband, then you'd think it's just solid and that wouldn't even matter to you. But people who are interested in seeing what's deeper, they will tell you that 95% on, I think, empty space. And this is really interesting. It was really interesting to us. So that reading this book, I was like really pondering on the question, how much reality do we, the humans, perceive? Like, how much of reality do we see? Because apparently we see more of a solid, or whatever our brain can perceive. And knowing that there's deeper like particles, and that is empty space that can be observed. If we observe them this way, can be waves, can be linear, I was wondering, how much of reality can we see as humans? How much reality can I see? And if the reality I see is really real, more so, or it's like more like my reality that I want to see. Although I'll tell you, it really still beats me to know that a chair is an empty space. It's like really hard to perceive that. And we probably, it makes me think that we cannot directly perceive these type of deep layers of realities, because we we can directly see electromagnetic effects. We can see stable matter and the way things behave on an average time length. There's a theory, I think it's called SU5. Yes, it's an SU5. It was in this book. And what it tells us is that a proton can, what's a word for it? Can decompose. I forgot the exact word, but it can be deconstructed into electrons and let me see, I have a note here. Into a proton can be, yes, into electrons and quarks, but it's like the equation for that, it's older than the universe. So we say it's impossible because we cannot perceive that, and we cannot really know that. There's no trace of that, like there's no video, no experiment that can be done for so long. So to us, that's unreal, and we really don't perceive the right, like, to the fully the quantum fields. We really try to understand it, and it's mind-blowing that there are quantum computers that they work, but we cannot explain how they work. Is that because we do not perceive directly the quantum fields or symmetry groups or probability amplitudes or virtual particles? Like, there's so much that we can only guess. Like, I like how the book brings up Einstein. How do you say Einstein? Einstein. They bring him up as someone who could imagine. He could imagine things. He didn't know for sure, but he could imagine. And then in time, it was proved. And same for us today. We don't see everything, and because we are used to see everything in a solid way, we cannot see unbroken symmetry. I like that, because we tend to see everything linear. We think time is linear, roads are linear, everything is linear. And that's why when someone tells us about quantum jumps or how you can do a quantum leap, we often think that that's nonsense because we cannot perceive it. It was interesting to me to find out how Albert Einstein, I don't know. Yeah, well, I'm not really sure how to say it in English, but I liked how he was talking about quantum fields as pockets of probabilities. So, if you think on that way, that everything in our life, it's like a pocket. So you're basically jumping from one pocket to another pocket, and you're jumping, if you think of observation, then you jump from this pocket of energy or quantum field to this one, which is basically something that you're observing. So it's really interesting. I'm like fascinated with all this physics right now. And I was thinking about the ocean waves, like at the first view, when you look at ocean waves, you can think that one wave is separate from the other wave and it's different, larger, smaller. And you can think they are separate, but in reality, they are all water, and it's an expression of the ocean. The ocean expressed itself in a smaller wave or bigger wave or dramatic wave or devastating wave too, So I was thinking that protons and electrons are like those waves, and then the quantum fields are more like ocean, So everything we see, it's the way it's just shown to us, not necessarily, or the way we perceive. Sometimes even when I liked how I was reading in this book a very interesting part, and that was in the 5th lesson, Grains of Space. And I liked how they explain, and it really, you think of it as an argument between two people, So if you listen to one side, makes total sense, perfect sense. And then if you think of the other side, then it's like the other side makes perfect sense. But when you put them together, they don't make sense. So it's like it's same with the physics with relativity theory, and also with the quantum fields. It's like really interesting. So it's just very amazing how we as humans perceive everything linear and solid and exact, you know, but in reality the universe is far more fluid than we can accept it. Everything around us are more fluid than we can accept. Even our thoughts, if you think how we are more on autopilot, let's say, rather than like constant thinking. So we see just what our brain selects to see, what's good for us in this moment based on what ideas we have or what we think, rather than reality itself. And it's really interesting that we don't see the reality as it is. We see it as it behaves at our scale, and our scale is determined really by the ideas we have, by life we have, you know, like it's really, this book is really fascinating. I'm right now on chapter 6, and I'm gonna make probably another video, but I just wanted to share with you how interesting that, if let's say you want to keep it very scientific, even science like physics, it really teaches us that reality is not object-based, but it's more like a process-based, and the whole life, it's process-based, you know. The only, how would I say that? The only things that are, let me see, the only things that are like, oh yeah, when you read about the, on chapter 2 about quanta, it's interesting. The idea that I got is that there's a sentence here that says that there was an objective reality independent of whoever interacts with whatever. And that's like, you know, our objective reality is that we're born, we live, and we die. But the quantum reality is that we choose, and we can choose how we live in this space. Like, we can choose to be a doctor, we can choose to be a nice child, listen to parents, right? Do have good grades, right? And we can choose to be someone who doesn't obey a criminal or someone bad. And everyone has their own, you know, ideas how they are justifying themselves. So, and it's very interesting to me. I'm not sure, I hope I didn't confuse you more than you were already, because you know, it seems like sometimes it's confusing, but I really recommend to read this book, seven brief lessons on physics. It's a really good book. I really enjoyed it. I mean, I'm still enjoying it, and I hope to let you know in the next video what else interesting I got from it. Well, thank you for your time, right? And thank you for staying with me and listening to it too.